Hi, here are the solutions to Algebra 2's practice test for Chapter 6. The first two, for number 1, rewrite in radical notation. So the base is 13. Now the fractional exponent, the denominator is the root, and the numerator is the exponent. For the next one, 3, base is 3, and the root is 5, so it's just a fifth root of 3. For number 2, they want you to change each of these into decimals. So in your calculator, if you have a cool one like mine, you take 105 to the 1/6 power to get the sixth root. Round that to two decimal places, you have 2.17. For the next one, the fourth root of 300, 300 to the 1 divided by 4, 4.16. Okay, now for the rest of them, we don't want decimal answers. We want you to simplify them. So for number 3, the base is the same. So when you multiply two powers together, the same base, you add the exponent. So it's 23 to the 2/5 plus 3/4. Okay, so we're going to have to add the exponents. They're fractions. The denominators are 5 and 4, so common denominator is 20. Okay, so adjust the numerators, multiply the denominator by 4. So multiply the numerator by 4 to get 8 over 20. For the 3/4, 4 times 5 is 20, so 3 times 5 is the new numerator. So 23 is the base. The denominator is 20. The numerator 8 plus 15 is 23. So we end up with 23 to the 23/20 power. Number 4, y to the 5/6 to 20 power to power, we multiply exponents, so y to the 6/5 times 20. Okay, 6/5 times 20 ends up giving you 24. So it's y to the 24th. For number 5, a to the 7/5 divided by a to the 3/5. When you're dividing two powers with the same base, you subtract exponent 7/5 minus 3/5 is 4/5. Number 6 is very similar. The only difference is m in the numerator doesn't have an exponent, so you know it's 1. So m to the 1 divided by m to the 2/5. You end up to 1m to the first minus 2/5. Well, 1 minus 2/5 is 3/5, so m to the 3/5. Okay, now number 7. We have two radicals. We can't subtract them right now because they're not exactly the same radicals. It's just like a like term problem. 11 to the square root of 5 is simplified as much as possible, but the square root of 20, we can rewrite it as 2 times 2 times 5. 11 square root of 20. Now, 2 times 2 is 4, square root of 4 is 2, so we can bring out another 2 to multiply by this 2. So we end up with 11 square root of 5 minus 2 times 2 is 4 times the square root of 5. Now the radicals are exactly the same, and we can subtract. 11 square root of 5 minus 4 square root of 5 is 7 square root of 5. Okay. Now, let's go on to the next list, 8 through 12. Let's see if we can get these done. Okay, number 8. The fourth root of 162, a to the 4th, b to the 9th. So we'll do the prime factors of 162. It's 2 times 81, which is 3 times 3 times 3 times 3. A to the 4th. B to the 9th, we want to split it up into 4. So b to the 4th times b to the 4th. Makes b to the 8th together. So we need one more b to the 1st. So altogether b to the 4th, b to the 4th, and b to the 1st make b to the 9th. Now we take out all of the parts that are to the 4th power. 3 times 3 times 3 times 3 is 3 to the 4th, and the 4th root of that is just 3. So that's going to come out as a 3. A to the 4th. 4th root of a to the 4th is a. Then a b to the 4th and b to the 4th. Taking out 2b to the 4th, so we have the b squared outside. Now, what's left underneath is the 2 and the b to the 1st. So the final answer is 3ab squared times the fourth root of 2b. All right, so that's number 8. Number 9, carve out a place for this. The third root, or cube root, of 24m to the 6th n to the 11th. We'll do the same thing as number 8. We'll go through and do the prime factors of 24. 24 is 2 times 12, which is 2 times 6, which is 2 times 3. So 2 times 2 times 2 times 3 is 24. And then we want powers of 3. M to the 6th, we can separate in m to the 3rd times m to the 3rd. Oops. Cross out that problem for now. N to the 11th. N to the 3rd, n to the 3rd, n to the 3rd. That makes 3, 6, 9. We need 2 more to make 11. So n squared. Now we look for powers of 3. 2 times 2 times 2 is 8. Cube root of 8 is 2. So we're bringing out 2. That 3 staying in. M to the 3rd times m to the 3rd. Bring those 2 out as m squared. N to the 3rd times n to the 3rd times n to the 3rd. We have 3n to the 3rds. So each one of those comes out as an n. So we end up with 3. So n to the 3rd outside. And the n squared stays inside. So to finish out the answer, cube root of 3n squared is left underneath the radical. The 2m squared n to the 3rd are outside. So there's your final answer for number 9. Number 10 I crossed out. I'll come back to that in a little bit. Number 11. We'll go through and do this before we finish up. 6 divided by the cube root of a squared. We can't take the cube root of a squared. We need another a, so we're going to multiply the denominator by the cube root of a. If we do it to the denominator, we have to do it to the numerator. So the numerator ends up now being 6 times the cube root of a. And the denominator, when I combine the cube root of a squared and the cube root of a, I put the cube root of a cubed. Now, the cube root of a cubed is just a. So my final answer there is 6 cube root of a over a. Okay, so we rationalized the denominator. Okay, we'll do 10, 12, 13, and 14 in the next video.